Hey guys, Mr. Ritz here to help you out on the next part of our factoring unit. So what we're going to be doing is solving by factoring. So when it comes to solving by factoring, the first thing we need to do is make sure that the equation equals zero. So we're going to start off pretty easy in this first day is that all the equations are going to equal zero. But that's the first thing, is that the equation has to equal zero. So you can see we have an equation equals zero, equation equals zero. All the equations have to equal zero. The next step we're going to do is we're going to factor. Now, factor is really generic. We might have to do GCF factoring at the beginning. We might have to do difference of squares. We might have to do trinomial factoring. But after we factor, what we're going to do is we're going to set each parenthesis equal to zero and solve them. Okay, and that means we're going to get multiple solutions because as we move on to higher levels of algebra, we have x squares. That usually means we're going to have two answers. X cubes means we could have three, and so on and so forth. All right, so let's go through this first problem here, GCF solving by factoring. So we're going to look here, okay, remember with GCF, we look to see what's the biggest number we can divide all three of these by. We got 15, 9, and 12, and I believe that number is 3. Then we look, they all have x's, so we're going to factor out an x, and we're going to factor out an x squared because they all have at least 2 of them. Okay, so we're going to keep the equal 0 just off to the side here, and we're going to go through and start dividing each term by 3x squared. So 15 divided by 3 is a 5x. Alrighty, a 9 divided by 3 is 3. We're just going to kind of leave it like that. And then the 12 divided by 3 is a 4. And we have x to the 4th. We're going to take away 2 of them. X squared. Okay. So we factored this. And what we would do here. Hold on one second. Okay, so what we're going to do next is we're going to set each part equal to 0. So this is going to be, all right, we're going to make a problem that's 3x squared equals 0. And then another problem we're going to do is this giant one, everything inside of that parenthesis, 5x plus 3 minus 4x squared equals 0. Okay, so this first one here we can solve. Okay, technically we could because we could divide everything by 3, right? And we get x squared equals, well, 0 divided by 3 is 0. And then to get rid of the square, we take the square root, and that would still be 0. Now this problem over here, we don't know how to solve yet. So we're going to kind of wait on those. We're just going to practice setting these up. We don't know how to solve these yet, but we're just going over GCF factoring just to kind of get used to it. All right. Next one here. Let's do this. So let's just practice our GCF again. What's the biggest number we can divide by? 4, 12, and 8. And that would be 4. And they all have x's. They all have at least 2. All right, if we divide 4x squared by 4x squared, that would be a 1, and there would be no more x's. All right, 12 divided by 4 is 3. We had x to the 4th. Got rid of 2 of them. We have x squared. All right, 8 divided by 4 is 2. We get rid of one of those. It's x. Okay, so same thing here. What we would do is we break this up into 2 problems. We'd say, okay, 4x squared equals 0. And then we would do, which you guys might see by now, that'd be 0. This one, we'd have 1 minus 3x squared plus 2x equals 0. We don't know how to solve that one yet, but we will. Tomorrow we'll go over those things. Can we actually do that one? 2 multiply gives -3, add together to get 2. We could do that one. Okay, but we don't know how to do it yet, so we're going to leave that alone. It's going to come back tomorrow. All right, the next one here. See, I don't think we could do this one. 20. No. All right, this one here. Let's keep this going. Okay, what can we divide 27, 18, and 9 all by? We can divide them all by 9. They all have at least one x. All right, if we divide it by 9, 27 divided by 9 is 3. X cubed goes down to x squared. Minus. All right, 18 divided by 9 is 2. All right, x squared goes down to an x. And 9 divided by 9 is a 1. That x goes down. There's no more x's. Okay. Same thing here. We would just say 9x equals 0. And then the other part here, 3x squared minus 2x plus 1 equals 0. We probably can solve this one here. Yep, 9 times 0 is 0, so x would be 0. We don't know how to solve this one yet, but we will. That one, I'm just doing in my head real quick. It does not come out nice. So this is why we're kind of skipping these. But what we want to go over is just the general concept. All right. So I don't really like doing those ones first, but let's do these ones here just to make our life easier. So to show you guys ones that actually do come out nice are like these differences of square problems. So remember, differences of squares are two terms with a minus sign in the middle, and we got to be able to take the square root of both of those numbers, which we can. And when we do that, we end up getting two very similar factors, except for one's plus and one's minus. So the square root of 25 is 5, and then that x, the square root of x squared is just x. So we got 5x plus something and 5x minus something. And the square root of 16 is 4. So we get two answers. One answer is 5x plus 4, one's 5x minus 4. So when we solve by factoring, all we're doing is taking one extra step of what we haven't done here. And we're going to take each part, set it equal to 0. The nice thing about these differences of squares is that the problems are going to be very, very similar. And the answers are going to be even similar. All right, so if we were going to solve this, 5x plus 4 equals 0, we would minus the 4 over, and we'd get 5x equals negative 4. Then we divide by 5, and this is why I like fractions, because I'm not going to do any math in my head. I'm just going to say it's negative 4/5. Now on the other one here, we would add 4 over, we'd get 5x equals positive 4, and we would divide by 5. And same thing, we're going to leave it as a fraction. That's a positive 4/5. And there's our two answers. Those are the two numbers we could plug in for x. And when we solve it, it turns out to be 0. So same thing, let's practice this next one. Do we have two terms with the minus sign in the middle? Yep. And can we take the square root of both of those? We sure do. So that means the difference of squares, we're going to get one's going to be plus, one's going to be minus. We're going to go ahead, take the square root of 81. 81 is 9. So we got 9x and 9x in the beginning here. And then the second part, what's the square root of 49? 7. So we take both of those and we're going to write our equation. We got a 9x plus 7 equals 0 and a 9x minus 7 equals 0. And when we solve them, you might be able to do this in your head. You're going to subtract 7 over. So we get a 9x equals negative 7. And when we divide by 9, we get x equals negative 7 over 9. You probably can already guess here, when we add 7 over, all it's going to do is just change it to a positive number when we divide. So we get a positive 7 over 9. So differences of squares are really nice because we get two very similar answers. One's positive, one's negative. The only other thing here to do is, what if we can't take the square root? So if there's a GCF that we can factor out here. So is there a number we can divide 12 and 27 both by? Yeah, we can divide them both by 3. So we're going to factor out that 3. So that becomes a 4x squared minus 9. And then we have to continue factoring. So 4x squared minus 9 is a difference of squares. We can take the square root of both of those terms. There's a minus sign in the middle. So the square root of 4 is 2. So we got a 2x at the beginning. The square root of 9 is 3. Now, technically, we set all parts equal to 0. So technically, we do make this 3 equal to 0. But that doesn't work. That doesn't solve. So we just cross it off. But we are going to have our 2x plus 3 equal to 0. And then over here, 2x minus 3 equal to 0. We're going to solve both of those. So we'll subtract the 3. 2x equals negative 3. You might be able to start doing these in your head without setting those up. It's just always the opposite number here divided by that. So same thing over here. We're going to add 3 over. 2x would equal positive 3. And when we divide by 2, X equals positive 3 over 2. Excuse me. So that's differences of squares. And the last type of factoring that we went over was factoring trinomials. So remember, when we did factoring trinomials, this problem's missing an equals 0. What we want to do is when we have 3 terms, all right, we're going to try to figure out, okay, what 2 numbers multiply together to get us the last number, and then add together to get the middle number. So we think about, or we use the times table here, and that would be 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. So we got an x plus 2 and an x plus 3. This is what we did not too long ago. So when we solve, all we're going to do is take our factor that we get and set each part equal to 0. So x plus 2 equals 0. We minus the 2 over. X would equal negative 2. Over here, we got x plus 3 equal to 0. We minus the 3 over. X would equal negative 3. So another way to think of it is it's just the opposite of what's inside the parentheses are the solutions. All right, so let's practice this a couple times. If you guys want to pause the video at any time to watch it on your own or try, you can. All righty. So we got what 2 numbers multiply together to give us 8, add together to get negative 6. All right, so that means they're both going to be negative numbers here, and that would be a negative 4 and a negative 2. So when we factor, it's x minus 4 and x minus 2. But you guys can see, like looking at the example number 9 here, whatever we have in the parentheses, we have the opposite solution. So if we have an x minus 4, our answer is going to be x equals positive 4. We have an x minus 2, our solution is going to be x equals positive 2. All right, a couple more here. Next one. Okay, what 2 numbers multiply together to give us negative 12, add together to get negative 4? You might want to think about subtract to get negative 4. All right, so that would be, if you haven't figured it out, that would be a negative 6 and a positive 2. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. So we got an x minus 6 and an x plus 2. So once again, going kind of with our solution rule here, what's the opposite of minus 6? Okay, that would be a positive 6. 6 minus 6 would give us 0. And the opposite of positive 2 would be a negative 2. Negative 2 plus 2 gives us 0. All righty. One more problem here. What 2 numbers multiply together to give us negative 27, add together to get 6? We get a negative number. They have to be opposite, so we're going to subtract. That would be a positive 9 and a negative 3. So we'd have an x plus 9 in the parentheses and an x minus 3. And when we solve these, remember, we just kind of write the opposite solutions here. X would equal negative 9 and x would equal a positive 3. Okay. So the next group of problems here, these factoring problems are your CYU problems. Go ahead, practice factoring them, see if you can figure out the magic numbers that multiply, and you hopefully can see the solutions are going to be the opposite of those. All right, you guys have a good one, and I will see you next time. Thanks for watching.